Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Yeah, welcome once again to this lecture, to this lesson. In today's class, we're going to be talking about the kinetic theory of matter. The kinetic theory of matter. Now, by the end of this class, you should be able to know the basic information about the kinetic theory of matter. Now, the kinetic theory. When you hear about the kinetic theory of matter, kinetic itself means movement. Kinetic energy. Okay? Energy that is being possessed in movement. Now, theory, I explained theory to you when I talked about introduction to chemistry, part 3. Okay? Now, theory is an explanation of an hypothesis in making it a law. In essence, it is the movement explanation of matter. Movement explanation of matter. Now, the matter itself is not talking about the states of matter. According to James Clerk Maxwell and Ludwig Boltzmann, in the 19th century, there are the two people that talked about the kinetic theory of matter. James Clerk Maxwell and Ludwig Boltzmann in the 19th century. They came to realize that matter itself is stable when change of state occurs. The state of matter itself is not affected when change of state occurs. In essence, it is the particles of matter that does this movement that brings about change of state. Because when a substance is being heated, there is a movement, rapid movement. Okay? The matter itself, you do not see the matter itself moving. Okay? You do not see the matter itself moving. What is moving are the particles of matter, which are the atoms, the molecules, and the ions. These are the things that causes this movement, that causes this change of state, I mean to say. Now, take for example, you keep an ice. You will not see the block. Okay, you will not see the ice block moving. The ice block will not be moving. What do you see? It will just be melting. In essence, its particles are moving out. Okay, and as they're moving out, the ice is experiencing a melting. So this is what the change of state is talking about. The movement theory of the particles of matter. Everything about the kinetic theory is talking about the particles of matter. Now, definition. Most people do not know that the kinetic theory of matter has a definition. They only know how to state it. They might tell you how to state it. It is from the definition you get a formula. It is from a definition you get an explanation. Every definition leads to a formula. Now, the kinetic theory of matter is the microscopic description of matter. The microscopic description of matter. Microscopic means something you cannot see. Now, what are the things that you cannot see in matter? That is what the kinetic theory is describing. Those things you cannot see in matter. And those things you cannot see in matter with your naked eyes are the atoms, molecules, and the ions, which are the particles of matter. Now, these particles of matter can only be seen with the scanning tunneling microscope. I repeat, these particles of matter can only be seen with the scanning tunneling microscope. Now, how do I measure the particles of matter? You use the mass spectrometer in the measurement of the molecules or the atoms. The measurement of the molecules or the atoms are being measured by the mass spectrometer. That is the same thing they use in measuring the atomic mass unit. Okay, so The definition, as you have seen, is talking about the particles of matter, how the particles of matter can be described in the movement of change of state, because it is the particles that causes change of state. So how can you describe it microscopically? These things you cannot see in matter are the particles of matter. So the definition, like I said, is the kinetic theory of matter, is the microscopic description of matter. Now, for these particles to move, okay, there is heat must be applied. That's why I brought that heat phenomena. For the particles to move, heat is applied. Now, when heat is applied, the particles move. Okay, the particles move. Sometimes the particles might not move if there is no heat. Particles might not move if there is no heat, because they need energy for their movement. I told you kinetic, so they need energy for their movement. So every movement energy is kinetic. And we know that heat energy is the energy of moving particles. In essence, it's the energy of the moving particles of matter, the energy of the atoms, the ions, and the molecules. And that particular movement is called heat phenomena. So the heat phenomenon states that the greater the thermal energy of the particle, the faster it moves. Now, people may say thermal energy and heat energy are the same thing. They are not. Heat energy is the movement, thermal energy is in position. Heat energy is kinetic, thermal energy is potential. In essence, it's in the position. Now, we know what thermal energy means. Okay, it is the heat that brings about the thermal energy. It is the heat energy that makes the thermal energy. It is heat energy that forms the thermal energy. And they say the greater the thermal energy of the particle, the faster it moves. Now, what is thermal energy? Thermal energy refers to the energy contained within a system that is responsible for its temperature. Contained means confined, taken. In essence, it does not move. Now, when this heat comes, the heat will be contained in its surrounding. You put a pot on the fire, okay, the heat comes out, and if you look under the pot and the fire, the heat is surrounded, the fire is surrounded under the pot. Now, that particular place where the fire is surrounded, the energy that this heat will give to that particular pot is thermal energy, and that energy will be responsible for the increase of its temperature. Why? Because the substances inside will have to move, and we know temperature is the amount of the average kinetic energy possessed by the particles of a body. So in essence, that temperature will increase because of the heat energy that is being contained under that pot. Through the thermal energy that is going under that pot through the heat energy that came out. Now the next one is the key points of the kinetic theory of matter. Number one, it stipulates the movements of the particles of matter. That is what it stipulates. That is what it's talking about. The movement of the particles of matter. The movement of the particles of matter. I told you the movement of the particles, how the particles move, the atoms, the molecules, and the ions. Now the second one is it is based on the atomic model of matter. Based on the atomic model of matter. Every particle, when I talked about atoms, I told you that the main particle of matter is the atom. In essence, in the atom, we get the molecules. In the atom, we get the ions. The charges in the atom are the ions, while the neutral part of the atom, which is the neutron, becomes the molecule. So, it is based on the atomic model of matter. In essence, atomic model represents the particles of matter. How do they model? How do they behave? How do these particles behave when heat is applied? That is what the kinetic energy is talking about. Now, the third one says, its aim is to account for the properties of gases in terms of the forces between them. In terms of the forces between them. Remember, we talked about change of state, okay? And this change of state is caused by the particles of matter. So the aim of the kinetic theory is to account for the properties of gases in terms of their cohesive forces, in terms of their forces between them. Now, these forces are cohesive. They are called cohesive forces. Okay? In terms of their forces between them, their characteristics, the characteristics of gases. Okay? In terms of how they change, that is the aim That is why they brought out the kinetic theory of matter. So that it's going to tell us how these gases behave, how are their characteristics, how do they form, how do they move, okay? How do they bring out their bond and force of attraction as they're going out? How do they experience themselves in the atmosphere? That is the aim of the kinetic theory. Now, the theory says it depends on the fundamental factor that are in the molecular constitution of matter, the identification of heat with the motion of molecules and the way the particles move in space. Now, this particular kinetic theory depends on the constitution of molecules in matter. How do the molecules constitute themselves in solid? How do they constitute themselves in liquid? How do they do that in gas? How do they do that in plasma? How do they do that in the Bose-Einstein condensate? How do they do that in the photonic molecules? How do they do that in the superfluid? How do they behave in the superconductors? And how do they do in the coagulant plasma, which is the quark soup? All of them have particles and molecules because they are being constituted with particles. Every matter you see in life is constituted with what? Particles. So how the fundamental reasons, the fundamental factor that this matter constitutes molecularly, and how do they identify with heat? When heat is applied, how do these particles move in space? How do they scatter in space? We talked about the difference between solid, liquid, and gas. Okay, how their particles are together in solids, how they are less loose in liquids, and how they are porous in gases. We talked about that. So the kinetic theory will explain, I told you the difference between solid, liquid, and gas in their physical manner. And I remember I told you that when you get to the kinetic theory, we are going to use that theory in explaining the theoretical aspect of the solid, liquid, and gas. Now, stating the kinetic theory. This kinetic theory was stated by James Clerk Maxwell. Stated this theory, okay, and Boltzmann. With Boltzmann and James Clerk Maxwell came together and stated this theory. And it states, all matter consists of many very small particles which are constantly moving. In essence, constantly moving means they have an energy called the kinetic energy. Because for you to be constantly moving, there's an energy you use, and that energy is kinetic energy. So because of the kinetic energy, they are constantly in motion, moving constantly. And we know that every matter consists of many very small particles. These particles are very small. Like I said, you cannot, that's why the kinetic theory is the microscopic description. The microscopic description. Okay? Now these particles that constitute this matter, every matter, they are very small. That is why they can have enough energy to move. Remember, if a fat man and a man that is lean, they tell them to run or they tell them to walk, for the first person that will stop is the fat man. Don't look at me, I know I have a big stomach, but I am going to move faster than you even if you're slim. Okay, so, but the fat man is going to stop before the slim man. Why? Because the slim man is tiny. So in essence, he is almost massless and weightless. So he can move freely. He can be in a constant motion on a steady. That is why the particles of matter are in constant motion, because they are very small. The particles of matter are in constant motion because they are very small and they possess kinetic energy. That is why they are in constant motion. Take note. Now the next one is the derivation of the kinetic theory. Where was this theory derived from? Where was it derived from? Number one, it says all matter are made up of atoms and molecules. All matter are made up of atoms and molecules. These atoms and molecules are the particles. In essence, they said all matter are made up of what? Particles. In the 19th century, James Clerk Maxwell used this in formulating the kinetic theory, because he knew that since there is a matter, then something will make up that matter. We talked about the quarks and the gluons. Someone talked about the coagulant plasma. Okay, the atoms are made up of protons, neutrons, and electrons, and the quarks make up the protons, neutrons, and the electrons. Okay, and something will still make up the quark. That is how it is. Particles come together and make up particles. So he came to know that atoms and molecules, something made them. So all matter is made up of atoms and molecules. And I said all matter is made up of particles. And he said the particles are in constant motion because they are small and they possess kinetic energy. That is why they are in constant motion. They are always moving. They don't stop. He tells us because they are in constant motion, they possess kinetic energy. Okay, because of this they possess kinetic energy because motion is kinetic. And the energy you get in motion is kinetic energy. Now the next one is the particles exert attractive forces on one another. As they move, they hit themselves. As they move, they hit why? Because they are scattered. They move randomly. When you're moving constantly, you move randomly. When you're moving constantly, you move randomly. So they move randomly. In essence, as they move randomly, they will definitely hit themselves. Now, they hitting themselves is attraction. If I'm walking, okay, and you come and hit me, in essence, there is an attraction of force. There is a force that attracted you to me and attracted me to you. Now, those particles exert those kind of forces on one another because they move anyhow they like. Okay, if I tell you to start moving anyhow you like in a class, you hit people, you start hitting people. That is how the particles of matter move. Now the next one says the nearer the particles are to each other, the greater the attractive force. Yes. Yes. If I'm to drag you to myself, as you're coming, the attraction is coming. It's like a magnet. Okay, if a substance, if a magnetic material is close to the magnet, its force is high than when it's far. Okay, so as long as they are near, that bond of attraction will be great, will be higher, because as they are coming close, there's a force bringing them together. Now, the assumption of the kinetic theory, the assumption, okay, we assume that, okay, this is the assumption, this is what they assumed, the people that brought out the kinetic theory. They assumed that the measurable properties of the states of matter reflect the combined actions of the countless number of atoms, molecules, and ions. The measurable properties of the states of matter reflect the combined actions of the countless number of molecules and ions. Yes, the properties of matter. So the kind of matter will determine the kind of number of atoms, molecules, and ions that will be present in that matter. The kind of matter will determine, you can call it kind of matter or state of matter or phase of matter. Either kind of matter, state of matter, phase of matter, you're correct. So the kind of matter or the state of matter or the phase of matter will determine the number of particles that will be present in that particular matter. You don't expect that for a metal, molecules will be greater than ions. I told you of elements being classified into metals and non-metals. So you don't expect that in hydrogen, or you don't expect that in a non-metal like oxygen, ions will be greater than molecules. Okay, so that is how it is. So the kind of matter determines the number of particles that will be inside, number of atoms, molecules, and ions that will be inside. Now, the kinetic molecular theory of matter. The kinetic molecular theory of matter. The kinetic molecular theory of matter. Now, matter be that it may, the kinetic theory, we know that mostly they use gas molecules in forming this kinetic theory of matter. So the molecular theory of matter will tell us the issue and the miracle behind this kinetic theory. Now they say matter is made up of particles that are in constant motion. Definitely you know that. They said all particles have energy, but the energy varies depending on the temperature the sample of matter is in. All particles have energy, molecular energy, but the energy varies depending on the temperature the sample of matter is in. Now, the temperature is the same as the energy. Remember, I told you that this kinetic movement, this temperature, depends on the kinetic energy that you possess. In essence, the faster you move, the faster the kinetic energy or the increase in kinetic energy leads to the increase in temperature. The increase in kinetic energy leads to the increase in temperature. So if these particles increase in kinetic energy, that means to say their temperature will increase. If the particles increase in movement, their temperature will increase. What do I mean? If the heat, okay, if heat is being acted upon on water, now heat energy is the movement of particles, atoms, molecules, and ions. Let's start with the particles of matter. Okay, now when the heat is applied on water, take for example, and the heat is low, the movement of the particles inside the water will be slow. In essence, the temperature will be low. But if you increase the heat and the movement will increase, now that movement is kinetic, like I said, and the kinetic energy and the movement increases, the temperature will increase, because as you're moving, you're calling heat to your body. Remember, when you're moving, sweat is coming out from you. That sweat is as a result of heat. So as you're moving, you're calling heat to your body. So the increase in the energy, in the kinetic energy, depends on the temperature the sample of matter is inside. Now, water is a sample of matter, okay? Liquid. Now, when heat is applied, the particles inside the water will increase. Now, when the heat is increased, the particles inside the water will increase in their movement, and as they're increasing in their movement, it is making the water hot. Remember, I told you that this change of state does not occur with the state of matter. It is not the state of matter that does any movement. It is the particles of matter that does the movement and causes the change of state, not the matter itself. Because if you're boiling the water, you cannot see the water moving. The water is not moving to anywhere. What you're seeing are those bubbles that are moving. Okay, those particles that will move and cause the increase in temperature. So the matter does not move, but the atoms and particles inside does the movement. And that is why it is the movement of the particles that increases or decreases the temperature of the substance. Remember, listen, it is the movement of the particles, the kinetic movement of the particles in matter, that does the increase in temperature or the decrease in temperature in matter, in any state of matter. So if it is a gas, it's the particles of matter inside the gas that will increase or decrease the temperature. If it's a liquid, the particles of the particles inside that liquid will increase or decrease the temperature based on their movement. Now the last one says the temperature of the substance is the measure of the average kinetic energy of the particles. I just told you that. That's what I just explained to you. So the temperature, the measure of the kinetic theory, the temperature of the substance is the movement. Okay, how the substances move. If they increase in movement, if they increase in kinetic energy, the temperature will increase. If they decrease in movement, temperature will decrease. Now I said take note, NB. This theory explains the forces between molecules and the energy they possess. Now the force between molecules that bond them together is called molecular force, while the energy they possess is called molecular energy. The energy that comes out from molecules, the energy that these particles of matter use in making their movement, is called molecular energy. Now this energy changes to kinetic energy. In essence, molecular energy is kinetic energy. It's kinetic. Okay? Molecular energy is kinetic. Is a class of kinetic energy. Now the force, remember, when they bring out their energy, the energy will bring out the force, and the force will make a movement, because what causes motion is force and friction. In essence, when this energy first of all comes out, it's going to bring out a force, and the force will make the movement kinetic. So the molecular energy will bring out the molecular force, and that molecular force will create the kinetic energy of the particles in matter. Now, thermal expansion of the classical states of matter. Thermal means adding heat, energy. how do this state of matter, how do they, what do you call it, how do they expand when heat is applied? Now for solids, they say when solids are heated, the atoms vibrate faster about their fixed point. The relative increase in the size of solids when heated is therefore very small. When these solids are heated, okay, they need a large amount of heat. They need a large amount of heat. Why? Because their particles are bonded together strongly, and that's why they have a fixed shape. So when they are heated, the atoms vibrate faster, and as they are vibrating about their fixed point, they are going out, they are losing, okay, they are spreading, they are running away, and as they are running away, what happens? The solid is melting. The solid is what? Melting. Why? Because when the solids are heated, the atom vibrates faster about their fixed point. They do not go out around that place, so they are going out. The relative increase of the size of the solid when heated is therefore very small. Why is the solid very small? It's because it is melting. The solid will experience melting when heat is applied. In essence, the heat applied on solid is used to separate the particles in solid, and as they are separating, they are melting. In essence, the temperature of the solid and the liquid will remain the same, will remain constant. Now, what are the particles? The particles are the molecules, okay? The atoms, the molecules, the ions. The particles are going out, okay? They are being separated because of the vibration. When something is vibrating, something will be falling out of that thing, because as it's shaking, particles will be going out. So the heat expands by melting. In essence, heat expands by melting. Heat expands by melting. So this heat that is being acted on solids, like I said, vibrates the solid. In essence, the particles are going out. So as the particles are going out, the solid becomes very weak. The solid is becoming weaker and weaker. Okay, as it's becoming weaker, it is melting to show its weakness. But that does not mean that the solid and the water that is coming out from the solid will have different temperature. They are going to be in the same temperature. Why? Because it is a phase. Melting is a phase, or is a point where both the solid and the liquid comes in equilibrium. In essence, everything about the solid will be the same as everything about the liquid. Everything about the liquid will be the same as everything about the solid. I told you that when I talked about change of state in melting. So the heat added, okay, is just to remove, the heat gained is to separate the particles, but they're going to be in the same temperature, So I told you solid expands by melting. Now the next one is liquids. They expand for the same reason, but because the bond between separate molecules are usually less tight, they expand more than liquids. Like I said, the particles in liquids are lesser bonded together than solids. Now they say for the same reason why solid expanded, that's the same reason why the liquid will expand. Now what is the reason? Heat. That's the reason. So when the heat comes, remember when heat comes on liquid, the liquid changes to gas. The liquid changes to vapor. Now this vapor comes with a pressure called vapor pressure. This vapor comes with a pressure that is called vapor pressure. Now the vapor pressure depends on the cohesive forces holding the particles. The vapor pressure depends on the cohesive forces holding the particles. In essence, if the cohesive force holding the particles is strong, the pressure will increase. In essence, if the temperature increases, the vapor pressure increases. If the temperature increases, the vapor pressure increases. Because the temperature brings out the cohesive force stronger to hold the particles together. So in essence, when the particles are held together, for the vapor to scatter it is going to increase its strength. In essence, vapor pressure depends on the temperature. It depends on the temperature. Okay, it depends on the temperature. So if the temperature is less or low, the vapor pressure will be less or low. If temperature is high, vapor pressure will be what? High. Now, evaporation. Now, when the liquid evaporates, it leads to the changing. Okay, we know that evaporation leads to the changing of a of a liquid to gas. In essence, when this particular thing is evaporating, when water is evaporating, it is reducing the volume of the liquid. Why? Because evaporation is removing the liquid as gas. I told you every single gas is a liquid because of condensation. So the liquid is changing to gas via evaporation. In essence, if the water is evaporating, if the water is evaporating, the volume of the liquid will be decreasing. Okay, that is why when you're boiling water, your water is decreasing because of evaporation. And now the evaporation is removing the heat from the substance. That is what causes what they call it. That's what causes the reduction of the volume. Okay, evaporation. When the water is boiling, the evaporation is removing the water from your pot through being a gas. In essence, he disguised himself. He changed to a gas to escape from the pot. So as that evaporation is occurring and that vapor is going out, that vapor is still water that is leaving the pot. So it is reducing the volume of the liquid, evaporation, because it is leaving the water as gas, and that water is still water. Now, that means to say liquids expand by evaporation. Sorry, liquids expands by boiling. Sorry, liquids expands by boiling, because when heat is added on a liquid, the liquid is going to boil, and when it boils, boiling changes to evaporation. So when it makes a liquid change to evaporation. So when that water keeps boiling, evaporation occurs. Okay, vaporization occurs, and the vaporization leads to evaporation. Now, as the evaporation is going out because of the boiling, it is removing the water from the water. It is removing the water from the water. What do I mean? The gas is water, so it is going out from the liquid as a gas. Sorry. In essence, it is going to reduce the volume of the liquid, because the liquid is escaping, but it's not escaping as a liquid, escaping as gas. So liquids expands by boiling. I told you solid expands by melting, liquid expands by boiling. Now, gases. Molecules within gases are further apart and weakly attracted to each other. Heat causes the molecules to move faster. However, gases that are contained in a fixed volume cannot expand. And so increase in temperature results in increase in pressure. Increase in temperature results in increase in pressure. Now, gases in a fixed volume cannot expand. When we get to the kinetic theory of gases, I will explain to you how the gas will expand. Okay? I'll tell you how the gas will expand. Now, the molecules within gases are further apart and weakly attracted to each other. Weakly attracted. They scatter. Okay, they move. They are loosed. Their particles are loosed. Their particles are loosed. So in essence, they are not attracted to each other. Now, if your father gave birth to 6 children, and he said, you people should spread around in the whole world. One should go to America, the other should go to Sao Tome and Principe, the other one should go to Haiti, the other one should go to London, and the other one should come to Nigeria. You people cannot be attracted to each other. Why? Because you are far apart. There's no way you'll be attracted. The only thing is the way you'll be talking on phone. You cannot be attracted. That is how the gas molecules are. They are spread like that. One is in London, one is in America, one is in UK. The other one is in Nigeria. That Buhari is ruling. So these particular molecules in gases are scattered. So the heat causes the molecules to move faster. They are already scattered. So when heat comes, they move faster. Now, but if the gas is in a fixed volume, the volume is fixed, they cannot expand. They can't expand. And so the increase in temperature results to increase in pressure. In essence, when the fixed volume and heat is applied, okay, the temperature, if the temperature increases, their pressure to move will increase. Their pressure to move will what? Increase. In essence, they now expand by evaporation. They will now expand by what? Evaporation. So gases expand by evaporation. Okay, why? Because when you say evaporation, evaporation is a random process. It does not have a direction, so it is scattered. And what evaporates are gases. Evaporation are gases. Okay, evaporation are what? Gases. So when they move, they are scattered, so they expand by evaporation. Now the next one, factors that determine the forms of matter. Further determine the forms of matter. Further determine the state of matter. You know about liquid, solid, and gas. Now, what will determine that this is a liquid, solid, and gas? The strength of attractive forces existing between the particles of matter and the molecular spaces between them. That is why I first of all talked about the thermal explanation, the heat explanation that causes this particular factor. Now, the strength of attractive forces existing between the particles. The attractive force in solid are strong. You know that. If they are strong, the attractive force between particles, between the atom molecules, and if they are strong and they are cleaved together, you know it's a solid. If they are somehow lenge, you know, they are not really strong, you know it's a liquid. If they are not strong at all, you know it's a gas. Now the molecular spaces between them, you know there is no, if they don't have space, because if they are cleaved together, there will be no space, you know it's a solid. If their spaces are small, not really big and plenty, you know it's a liquid. But if there is no space, and if there are many spaces, whole, you know it's a gas, because the gas will out indefinitely. Now we've come to the end of this section, but before we leave, I think we should use the exam guide to quantify what we have learned and how to go about this particular lesson. Now, we are in exam guide year 2005, question 26. Question 26. They said, when ice is changing to water, its temperature remains the same because the heat gained. Yes, I think I told you that. I don't even know that the question will come to this place. I think I told you that when I was talking about solid, a thermal expansion of solid. I told you that when heat comes, it makes the molecules to scatter. In essence, as they scatter, they are separated. As they scatter, they are separated. So the heat gained is used to scatter. Okay? When it is used to scatter the molecules, to separate them. Because when they come, as they are scattering them, as the molecules are leaving the solid, the ice, as the molecules are leaving the ice is losing its strength. And as the ice is losing its strength, the ice is melting. So the separation of these molecules leads to melting. In essence, what leads to melting is the separation of molecules. So the answer is used to separate molecules. Now, our next question in the exam guide is 2012, question 14. 212, question 14. The vapor pressure of a liquid depends on, I just told you that. They said 1, temperature. 2, they say rate of condensation. And 3, cohesive forces holding the particles together. I told you that the vapor pressure depends on this, the temperature. Okay, when the temperature increases, the vapor pressure is going to increase, because the temperature leads to rapid evaporation, and evaporation to rapid vaporization, and vaporization leads to evaporation. Now the vapor, for the temperature to increase, that means the water or the liquid will increase in vapor. That means the pressure of the vapor will increase when it's coming out. Now, for the vapor to experience its evaporation, it's going to scatter the particles that are held in cohesive forces, like I told you. So in essence, the force that is holding these particles is going to scatter it. And for it to scatter it, it's going to need more pressure. Why? Because the temperature has increased. And that temperature has increased the cohesive forces of the particles that led to its pressure coming out. So the answer is temperature and cohesive forces. 1 and 3 only. Because condensation is changing of gas to liquid. Now the next one is 2014. 2014, question 22. 214, question 22. 214, question 22. This will be the last one we'll take. The vapor pressure of a given volume of liquid increases when the vapor pressure of a given volume of liquid increases when. Now, we know that when the vapor pressure of a given volume of liquid increases, okay, something increases. Something increases. I just told you that when temperature increases, pressure will increase, because they work in a parapassoir. Okay, when pressure increases, temperature increases. When temperature increases, pressure increases. So the vapor pressure will increase. The pressure of how the vapor will come out from the liquid will increase when you increase the temperature. If you reduce the temperature, you lower the gas, the vapor will reduce. So the answer is when the temperature of the liquid rises.
Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.